Let's solve a couple pretty easy logarithmic equations by using the definition of logarithm that's listed here in the red box in the middle. So on these, they're kind of the special cases that we mostly just need to know what the base of the log is. So when we switch over to exponential form, because we start with logs, we want to go to exponential form. The solving down should be pretty easy. Just need to know exactly what the base is. So I always like to identify that first, and then write that base, and then rewrite it in an exponential form. So it's good to note, on the left-hand side, we have a natural log, an ln. Natural log automatically means log base e of x, in this case, equals 6. So we can replace the natural log, and sometimes just writing this out helps students as they're working on, all right, I got to identify that base first, and then switch over to exponential form. So our base in this case is going to be e. And this kind of looks like it's e raised to the x power in the line above. So when we rewrite it, it's not going to be e raised to the x power. Instead, we're going to use the 6 from the other side. And we haven't used the x yet. It ends up on the right-hand side, just like the definition says there in the middle. All right. So we have x isolated on one side. E's a number, remember? So we have all numbers on the left-hand side. That's a nice exact answer. If you were asked to, you can get an approximate solution by using second ln on your calculator. And this works out to be about 403.42879 ... keeps going. All right, on the right-hand side, let's try to solve that one as well. We have a common log in this case where we don't see a base identified. So that's automatically log base 10. Pretty similar solving down now that we know what our log is, or what the base of our log is. We'll start out with that 10, the base. It's not going to get raised to the x power. Instead, it gets raised to the third power, and the x goes on the right-hand side. All right, so x is already isolated. Like I said, pretty easy problem here. And we can compute 10 to the third power is 10 times 10 times 10, or 1,000. And there's our nice exact solution. All right, hope this helps out as you're working on understanding natural logs and common logs, identify those bases, and then get down this definition of logarithmic function so you can go from logarithmic form to exponential form.